Good afternoon. I hope you're all well. My name is Tarek Sobh. I am the Dean of the College of Engineering, Business and Education at the University of Bridgeport, and I'm also the University Executive Vice President. For the next 15 or 20 minutes or so, I'm going to talk a little bit about the future of engineering and technology in the 21st century. In particular, I'm going to talk about the jobs of the future and the kind of training and the kind of education, research, interdisciplinary and experiential programming that would enable our students to perform well in future careers. I come from the University of Bridgeport. University of Bridgeport is one of the most eminent STEM-oriented and professional-oriented universities in the northeast of the state of Connecticut. We are a research doctoral university, very well known with an incredibly long history of accomplishments in research and development and education in various STEM, that would be science, engineering, technology and math, business, education, health sciences, and various professional fields, graduate programming and pre-programming. The university is actually home to the largest graduate engineering program in the state of Connecticut and second largest in the region of New England in the US. Again, talking about the careers of the future, it's kind of interesting because in this time and day, there are job titles that didn't even exist 15 or 20 years ago. Job titles like nanotechnologist did not exist. Job titles like autonomous car engineer did not exist 10 years ago. Even job titles like social media marketer did not exist either 10 or 15 years ago. And the reality of education in the 21st century is going to be continuing along these lines. We continue to prepare our students for job titles that don't even exist. What does that really mean in terms of the education that we should disseminate to our students and the research experiences that they should be undergoing during their undergraduate and potentially graduate studies in engineering and professional fields? What it means is that we should be exposing our students to a wide variety of interdisciplinary programming and provide them with a depth of knowledge in various disciplines that enable them to be nimble after they undertake their careers upon graduation. There is no question that there has to be a specific depth of knowledge in one or more areas to be studied during their undergraduate years, whatever that is: electrical engineering, mechanical engineering, technology, mathematics, the sciences, computer science. But importantly, there should also be dissemination in a breadth of areas, not necessarily very closely related to their main focus and area of study, in order to enable them to be lifelong learners and be able to understand and actually function in future jobs in which they continue to need to learn as they progress. Very good examples of areas like this include, for example, existing fields like robotics and automation, artificial intelligence, data analytics and business intelligence, nanotechnology, and many other fields. A great example would be the interdisciplinary programming going on at the University of Bridgeport within an area like robotics and automation, artificial intelligence. The University of Bridgeport is home to the RISC Lab. It's an interdisciplinary lab within the School of Engineering, actually across the campus. And that particular lab is actually home to many students from several departments working on truly exceptional projects. The Robotics, Intelligence, Sensing and Control Lab at the University of Bridgeport has undergraduate and graduate students and doctoral fellows, postdoctoral fellows, faculty members from the departments of computer science, working on algorithms to move and control and do analysis of the scenery that autonomous vehicles are seeing and for controlling manipulators. From mechanical engineering, working on the design of these prototypes and for these It also includes people from the Department of Mechanical Engineering and Biomedical Engineering working on things like biomechanics and ergonomics. It includes mathematicians from the Department of Mathematics and mathematics students working on the geometric structures of manipulators. It includes computer engineers working on algorithms and artificial intelligence structures for controlling undermanned air vehicles, for controlling robotics and manipulators, and for controlling submersibles and submarines autonomously. It includes biomedical engineers also working on things like prosthesis and so on. And this is very symptomatic of the education and research that would be really conducive to producing future professionals. Whether the area again is robotics and automation, machine learning, deep learning, cloud computing, biomechanics, software engineering, and or other areas like green engineering and sustainability, smart cities. All of these careers and all of these disciplines exhibit the need for cross-disciplinary programming. At the University of Bridgeport, we are very proud not only of our research and development accomplishments and external funding that actually enables our students to do well. We are very comprehensive. We are a doctoral research university. We actually are the School of Engineering that is one out of 3 doctoral schools of engineering in the state of Connecticut, meaning offering undergraduate, graduate degrees, and PhD degrees and master's degrees in all the disciplines of engineering, or most disciplines of engineering. And that's actually kind of important even for undergraduates and master's degree students to go to a doctoral research university, because it means that the facilities are very significant. Again, being part of 100 plus or so universities that are home to a doctoral school of engineering makes our programming kind of really interesting and exciting. We offer undergraduate degree in computer science, computer engineering, electrical engineering, computer engineering technology, and mechanical engineering. We also offer master's degree programs in the areas of computer science, computer engineering, mechanical engineering, technology management, biomedical engineering, and also, as of recent, a newly developed Masters of Science program on artificial intelligence. And at the PhD level, we offer programs in computer science, computer engineering, and technology management. Within the School of Business, we offer programs in data analytics and business intelligence. We offer programs, meaning at the master's level, we offer a program at the master's level in finance and MS in finance program.